Hello, I'm Alan Folmsby, and today I'll be talking about force. And in the particulate theory of relativity, the proton is very important, and the volume of a proton per second is defining force. So I'm going to be presenting some concepts quickly, and then I'll go back in detail about the mass equals area theory. Then the new formula for the gravitational force replaces Newton's, and Newton's constant is replaced. Then we'll talk about electric force being a new formula instead of Coulomb's formula. I'll go into these details. Now, universal constants are redefined, and then I'll review these things and highlight the basis of all of this. Now, the part of this is about the electron and proton communicating with 2 dimensions of space, but gravity using 3 dimensions of space and time flowing the other way. Force, something everyone is familiar with. Now, gravity is proportional to the proton volume per second. And this is a new quantum number, really, the volume of a proton. And the time constant, tau, we'll talk about in a minute. Now, this is based partly on the mass equals area theory. And you may have heard the old expression, force equals mass times acceleration. Well, there's a new poem, force equals area times acceleration, since area is mass. And area is proportional to mass. And in fact, there's very little offset between, say, a proton or a neutron cross-section and the area and the number of kilograms in a proton or neutron. So, in fact, even though we'll be using 1 kilogram equals 1 square meter, that is because at the bottom we see here that ratios of masses cancel out any scaling, and that even mass over charge areas cancel out any scaling. So it is accurate in most physics. There are formulas using these ratios of masses and the mass to charge ratio. So it all works out well so that the force equals the abstract units of cubic meter per second squared. Now, the gravitational force has been redefined. Newton's equation is replaced by this one. The force is equal to 2 nm r cubed over 3 tau second r squared. So basically n is the number of protons and neutrons in a little test mass. The large N here is the number of protons or neutrons that have the volume involved, and which is r cubed, is proportional to the volume. Divided by 3 times the 5 nanosecond time constant tau per second per r cubed, r squared rather at the end. The big R is the distance between the small test mass and the planet. Now, you notice the force is proportional to the proton radius cubed divided by the big radius squared. And we'll be comparing that with electric force later. So that force, the magnitude of force, is set by the radius and also scaled by the proton mass and the 5 nanosecond time constant. And by doing this, Newton's gravitational constant has been redefined. Instead of it being 6 times 10 to the minus 11th newtons times some units, here we see it is r cubed over tau divided by m seconds. And 2 is in there. So m is the proton mass, and the 1 second is in there because we did a 1 second drop test. I'll be explaining that at the end. And the proton radius, the small r proton radius, is 0.95 femtometers, 10 to the minus 15th meters. Now the electric force is pretty similar to that, in that the electric force is redefined of 255 newtons multiplied by the two charges and the scaling constant, the radius of the proton squared, divided by the proton charge squared, and divided by the big R squared between two objects. And you notice that the force is proportional to the proton radius squared divided by the distance between the two objects squared. So that's different than gravity, and that's why it's so much stronger. It's radius squared instead of the radius cubed of the proton. And then further scaling is by Q, is what our modern science calls the proton charge, and also the fact that Q is part of an 8-dimensional physics that has an internal time-like membrane spline. So I've redefined the universal constants. G is this formula here, r cubed over tau divided by 3m seconds. And the Coulomb constant, K, is 255 newtons times the proton radius squared over the charge squared. Notice that when two protons get close together, like one radius away from each other, they have 255 newtons of force pressing them apart, just as the old science said. And so the universal constants, tau is 5.13 nanoseconds here, r is set to 0.95 femtometers. A new universal constant has been recognized. It's the momentum of free space per baryon. It's called P, which is the volume of a proton divided by 5 nanoseconds. And its value is 7 times 10 to the minus 37th cubic meters per second. Now let's review what we talked about. This first equation is Newton's equation of a G, of the force of gravity, big G times the two masses divided by the radius. Now, this is converted into the things I've been talking about by recognizing that the two masses, m1 and m2, is really n times the proton mass. So n is the number of protons and neutrons in a planet. And m2 is small n times the mass of the proton, so that we can then convert that between Newton's formula and the new modern formula. And that's shown here, how the NM here at the end is converting everything. And it all works out so that the force is a kilogram meter per second per second. All based on gravity volume theory, which produced the momentum of free space equation right here. On the left is the momentum NV, the number of proton volumes and neutron volumes divided by 5 nanoseconds, is equal to AZ, the volume of a fallen shell, divided by the 1 second test time. Now, A is the area of the Earth, and Z is the height fallen in 1 second, 4.9 meters. So now, part about this presentation is just one more thing. It's the two-dimensional nature of electrical force and the three-dimensional ratios for gravitational force. Now, you can see it in this diagram here. I'm showing these three black dimensions. There's a blue proton and a black electron here. So that three black dimensions are going into the proton, and time is coming out of the proton. You see it's expanding space, the black space all around the proton and electron here. There's also a neutron here, which is connected through one dimension. Now, there's a mirror inside the proton. So these three dimensions are reflected in a mirror to produce these three red dimensions that bounce back outwards. Two of them go to the electron, and one of them to the neutron. Now, like time, going the other way of space in this diagram, time's going out, space is going in. Similarly, for the electron, magnet time is coming out of it in this arrow, yellow, and magnet space is coming into it in 2 dimensions. So it's rather a membrane, a 2-dimensional membrane with a contraflow time-like dimension going the other way. And in this way, all the electromagnetism works out perfectly. And the force between 2 protons has been described in today's lecture. Thank you. Goodbye.